Hi and welcome to the channel. If you're new here, please consider subscribing and ringing the bell so you don't miss any future video. Now the following video is a lecture that I did at a university here in Sydney as part of a partnership that I have with my company. In this lecture, we demonstrate the vulnerability of IoT devices, specifically this security camera right here. We performed a live hack to demonstrate these vulnerabilities, but to keep this within a 20-minute time frame we had to try and speed things up a little bit. So just keep that in mind as you're watching. Anyway, enjoy the show. Leave your questions or comments down below and smash that like button. And I'll see you in the next one. Okay, so what I'm going to walk through is a bit of a live hack demo of a IoT device. It's a hypothetical scenario if we've got a target in mind, and because we haven't got access to any of the devices here at UNSW to pen test, so we'll simulate it as a bit of a fictional scenario. Before I get started, reiterating on what Ed said, do not do this at home with devices that you do not own. It's a good way to kill your career before it starts. Alrighty, so let's get into it. Got to remember what I was going to do now. So what I'm going to do is basically run over the methodology that a pen tester or possibly even an unethical hacker will take based on what Ed went through in the slides. Keep in mind, this is very accelerated to fit in a 15 to 20 minute time frame. This will generally take a lot longer and a lot more trial and error. Things should probably, hopefully, go quite well. So let's start by taking a look at Shodan. And say we're some cyber criminal, or we got really bad marks at uni and we're pissed off. We want to hack UNSW, right? So let's have a look, see what devices UNSW have out on the network. So we use Shodan, which Ed mentioned, it's like a Google for IoT devices, or basically anything connected to the internet. And it will basically do a port scan and it will pull back banner information for IoT device right there. It will pull back the banner for every port that it finds and can communicate to. So let's have a look at what we have here. So we've got a Citrix gateway, AWS, Engineering Society. I think I saw a Minecraft server here. And let's just say hypothetically, there's a security cam that we've found in here. We think that it could be vulnerable and we want to attack it. So let's just imagine that, yes, it's the Engineering Society one. We can click into that. We can see that, okay, ports 80 and 443 are open. So let's have a look and see what we get. All right, so engineering site website. Cool, so in this scenario, we'll attack the following IP address, which is 192.168.2.3. And we can see here that we're greeted with a login message. And we've got a bit of a clue here. We see DCS 5020L_72. Now, to me, this seems like a model number of something. And because we already know that we're kind of looking to attack a security camera, this is a really good place for us to start. So we'll come back to this in a second. But for now, let's just see what we can find on Google for, say, the default credentials. So default credentials, 5020L, pardon my spelling. Okay, and it looks like the default password is, username is admin and the default password is empty. So we can give this a try. No luck, okay. That's fine. What we'll do while we set up more advanced attacks is see if we can just do a brute force attack. Brute force attacks are cheap, they're easy, but it's something we can set and forget while we look at other exploits, other vulnerabilities. So what I'm launching here is a tool called Burp Suite, and this is kind of like our Swiss Army knife when it comes to pen testing. It's really handy for us to do anything with HTTP traffic. It basically lets us edit any payload before it goes out of the network. So it's useful for doing anything like injections or brute force attacks, basically anything that you can think of that you want to partially semi-automate or just fiddle around with. It's really handy for that. So I've already got a proxy running on here, so I'm just going to use Firefox because it's already configured to use this Burp proxy. And instantly it's captured something from Firefox. Let's just disable that. So let's hit that IP address again, 192.168.2.3, and we're at the same login again. So we'll type in admin. Because we don't know the password, we'll leave that blank. And let's see what this looks like. So here is the GET request that it's being sent out to try and authenticate us into the management page for the webcam. And something to note here is that we have an authorization string here in the HTTP header. For anybody who knows what that is, that's basic authentication. It's not the most secure form of authentication nowadays, and it's easy to play with. So what I'm going to do is I'm going to send this to the intruder module in Burp. And this allows us to basically substitute parameters so we can try and substitute a password. So what I'll do here is just add a parameter at the end here with these little curly dollar signs. And then we'll go to payloads and we'll load up a text list full of passwords. Now, the text list that I am using is called produ.txt, and produ is based off a very famous text list called rocku.txt. For those who aren't aware, Rocku was a bit of a gaming website back in early Facebook days, and they got hacked, and I think about 14 million passwords got leaked. So it's just a fantastic place to start whenever you're trying to brute force something, because you've got 14 million original passwords to play with. Produ, however, is only 3,500, and for this demonstration, it's a bit more suitable. So what we need to do before we send out the payload is two things. First, we need to make sure that it is encoded back into base64, so that way it is matching the convention that's expected. And we just need to turn off URL decoding, so any special characters won't get encoded into the %20 signs and things like that I'm sure you've all seen. Lastly, we'll just set a few more threads to hopefully make it go quicker, and we'll start the attack. So as we can see, a heap of 401s, which is just access forbidden, and let's just hide these because they're not relevant. When we get a HTTP 200, meaning everything is okay, it should come back up here. Now, in the interim, we can have a look for some published vulnerabilities for this security cam. So a good place to start is, of course, Google. And we Google CVE. CVEs are what's known as a common vulnerability. So every time something gets hacked and the vendor acknowledges that this is a security exploit, they publish a CVE telling people about the hack and how to get themselves to be protected from it. So it's basically a notice saying, hey, yep, like a recall notice, just saying, hey, yep, we've got a problem with this. Here's what you need to do to fix it. So CVE Details is one of the best sites that we use for this. And this looks like the relevant page. So we can see that there are two vulnerabilities for this. There's one for code execution, which sounds pretty interesting, and there's one for cross-site request forgery. Less interesting, but it could be useful. Let's have a look at the code execution. So this has been given CVE number 2017-17020, which will be helpful for us when we're Googling around trying to find how to actually pull off this exploit. Because generally they tell you that there is an exploit, rarely do they tell you how to do it. So we'll just look through the references, but first we'll look at the scores. So we can see that it's got a partial impact to confidentiality, integrity, and availability. and it's got a relatively low complexity to pull off this attack. So that looks pretty good for us. There's two references here, one from, it looks like, D-Link confirming it, and one for the actual camera. Cool, so spoiler alert, I've read this before in preparation for this talk, but essentially what these guys did was really, really impressive. What they did was they got a firmware update, and instead of installing it like most of us do when we get a firmware update for our phones, they decided, okay, let's decompile it. Let's look at the code, let's look at what's in it, and see what we can find. So what they did was pretty clever. They decompiled all the binaries and had a look through it, and they did a bin walk. So that's basically looking for text strings within the files. And generally, when you're doing this, one of the best words to search for is password. As we can see, there's a few mentions of it here, and I think the author has intentionally cropped this, but we can see that on this line and the line below, there are some mentions of some input being overridden to the etch password file. And for any of us who have played with Linux systems, we know that the etch password file is where all the system passwords are stored and user accounts. So they did a very low level analysis going all the way down to assembly to see how all these strings are being executed and moved around the application. And they concluded that this was actually happening in the change password field. So what they were able to do is within the admin ID parameter of the change password field, do a code injection, which will allow them to run code on the underlying system and spin up a telnet server, so then we can then connect into the camera. So who's heard of this SQL injection before? Probably some people, yeah, most of us. So code injection is basically the same thing, and as I mentioned, it executes code on the underlying system, and it works off the same parameters by basically tricking the underlying application to accept the input and then allow us to specify our code. So we'll give that a try, but let's have a quick look at the intruder. And it looks like we've got a HTTP 200 now. And this is the authorization string. So what we can do in Burp, it also has a handy little decoder function. So we can decode from base 64 into plain text. And it looks like the password is I love James. Have we got any Jameses here? No Jameses? Ah, damn. Sorry, James, we love you still. Okay. So what we'll do is we'll use this username and password to try and get into the management interface of the webcam. Admin, I love James. And does James love us back? He does. Excellent. Okay, we'll just open this in Internet Explorer because it is not designed for Firefox very well. 1, 2, 1. Cool, so it looks like we've gotten into the web interface of the security cam. So we've done our job right? We can probably have a bit more fun. Oh, and we can see everybody here. Wave to the camera. Hey, one person waves. I wonder how we can get this thing to focus properly. Okay. So as the exploit mentioned, this was done in the change admin password functionality. So let's have a bit of a look for that. Network setup, DNS, maintenance, admin, here we are. So we can try this injection and see what we get. Because we don't want to raise any alarm bells, I'll keep the password still as it originally was. So I love James, and I love James. I really don't love James, sorry. We'll put our intruder back on. So this means when we go to submit this request, it will go into Burp and we can play around with it again. What was I in? Sorry, I need to do it from Firefox. Hopefully I typed it right. Okay, so this is the password change request going in. Any of you, I'm sure most of you have seen a HTTP post request before. The parameter that we're looking at is admin ID and admin there. So that's where we're going to perform our code injection. So we'll reference the article again. Wherever it went. Okay, so this looks like the text for the code injection. So basically we're changing the admin ID from admin just to A, and then we are doing quote telnet D. Okay. Oh, I think I typed that wrong. Telnet D. Okay. All right, so let's forward this on, and fingers crossed that if we try to telnet to this IP address, we will get a session. And that's because I didn't type telnet. And we've got it. So we've managed to start a telnet server running on this IP cam. So now we just got to log in. So we just changed the password to A. And the password, hopefully, should still be I love James. And now we're in. So we've effectively just hacked into this security cam here. So you can see that it's running BusyBox version 1.12.1, which is a built-in shell. So what happens if we do just like a ls? We can see a standard directory structure. And to many of you, this might start to look familiar. And you'd be right in thinking that, because maybe we could do cat etch password, and we found the password file. So for this tiny little security camera here that looks like it just functions as a camera, underneath all of its bells and whistles, it's basically just a Linux operating system that is used to control this camera and a web interface. So from here, we could pivot our attacks, which means use this webcam as a way to go throughout the organization that's running it, into their internal network and cause all sorts of havoc. We could install crypto miners on it. We could hijack the video feed. The opportunities are endless, and I'll leave that to your imagination to think of what we could do next. But that kind of leads me to kind of like my concluding remarks. So we tend to see IoT as these new emerging flashy technology which we need to drop everything and focus on how to prepare ourselves for it. And that is partially true. I agree with that. But as we've demonstrated today, this IoT device uses the same underlying software, operating system, protocols as computers have been for the past 30 years. So I like to think of IoT not so much as a new type of technology, but more a new purpose for technology. And it's in that purpose that we can create these new vulnerabilities, and that we need to make sure that we're secure with these devices, especially if they're exposed to the internet. So that practically wraps it up. Ed and I are happy to take some questions for the last 10, 15, 20 minutes, however long we've got. 20 minutes?
Thank you, guys.